We're back for the next 5 videos on this playlist of practice final exam. A city's population in the year x equals 1965 was y equals 886,850. In 1991, the population was 880,350. Compute the slope of the population growth or decline and choose the most accurate statement from the following. The population is increasing at a rate of 450 people per year. The population is decreasing at a rate of 50 people per year. Increasing at a rate of 50 people per year. Decreasing at a rate of 450. Decreasing at a rate of 250, or increasing at a rate of 250. We want to calculate the slope, and we have a formula for calculating slope, which is y2 minus y1 over x2 minus x1. That's the change in the y values over the change in the x values. So we're given x equals 1,965 or 1965 with a population of 886,850. And then in 1991, that will be our value of x, 1991, with a value of y of 880,350. So in calculating the slope, we're going to subtract the y values, 880,350 minus 886,850 divided by, and when we subtract our x's, we want to make sure we subtract it in the same order. Since I did this y minus this y, I need to make sure I do this x minus this x. 1991 minus 1965. So I've got my calculator here, and 880,350 minus 886,850 is a negative 6,500. 1991 minus 1965 is 26. Let's do that division. 6,500 divided by 26 is 250, and that's negative. The negative indicates that our population is decreasing and the slope is decreasing. We're decreasing at a rate of 250 people per year. So this is the correct statement. For this question, we want to use the graph to determine the domain and the range of the function. So here we have this graph, and we want to find the domain. And the domain is the set of all first coordinates, or x's. So our x scale is this horizontal scale. We call it the x-axis. And we want to determine which x's are a part of this graph. So this one's an interesting graph because as we look at the line, we can see that the line goes off screen here. And when it goes off screen, we assume that that pattern continues. So if they had drawn the line and then there was a stopping point, it would mark it that way. But this one goes off screen. And so we want to say that that pattern continues, or we assume the pattern continues. And the same thing with this line right here. So with that in mind, with this graph continuing this pattern is going down and to the left. It will continue to go down and to the left, and that tells me that all of these x values are a part of our graph, and continuing on forever going to the left, because that pattern goes on forever to the left, we can say that all of these x's are covered, and with this one going down and to the right, that means all of these x's here are also included in the graph. So the set of x's we're talking about are all real numbers. Our domain is all real numbers. And there are several ways to represent that. We can say the statement all real numbers. We can use this symbol right here. This is the symbol for real numbers. It's an R with a double bar here. And we can also write it in interval notation. Interval notation is got a lower bound and an upper bound. And since we're saying there is no upper bound or lower bound, we use infinity and negative infinity to indicate that it goes on forever in both directions. So no lower bound, no upper bound, negative infinity to infinity. And then we also want to find the range. The range is the set of all second coordinates or y's. And our y scale is this vertical scale. We call it the y-axis. And we can see that on this picture, we get to a peak and then we turn around. So our highest y value is 3. And all of these other y values that are below 3 are found on the graph. And remember, we have those arrows indicating it goes on forever. So our range is all real numbers that are less than or equal to 3. And we can say that y is less than or equal to 3. We can also write that in interval notation. That would be negative infinity to 3 with a bracket. The bracket on the 3 indicates that 3 is a part of the set. And our lower bound is negative infinity since it goes on forever. So there we have our domain and range using this graph. On this question, we want to select all of the graphs which represent y as a function of x. And to do that, we're following the definition of a function. The definition of a function is that every x has exactly one y. And we have a way of determining whether a graph is a function using the vertical line test. So we're going to perform the vertical line test on each one of these graphs to see if the graph is a function. Now with the vertical line test, we draw vertical lines all over the graph, and we're looking for how many times these vertical lines intersect the graph. You can see that by drawing these vertical lines, each vertical line only has one intersection point for this particular graph. So because it has one intersection point, that means we have one x for every y, and this one is a function. So let's do that on the next graph. We'll draw vertical lines, and every single one of these vertical lines crosses the graph in only one place. That means that every x has one y, and this graph is also a function. Okay, let's take a look at the next one. I draw vertical lines. Every vertical line is intersecting the graph in only one place. and that makes this graph a function as well. Take a look at the next one. We'll draw vertical lines. Every one of these vertical lines intersects the graph in one place. So we have a function. And the next one. Here, if I draw vertical lines on this middle section here, these vertical lines intersect the graph in more than one place. So here I have one x value with multiple y values. So this represents one x value with 3 different y values, and that violates the definition of a function. So this is not a function. On this one here, we draw vertical lines on the circle. Some of these vertical lines are intersecting in more than one place. So that violates the definition of a function, and this circle is not a function. So we would select these 4 graphs to represent functions, y as a function of x. For this question, we want to graph the equation y equals negative 1/4 x plus 3. The equation is written in slope-intercept form, y equals mx plus b. We have y equals negative 1/4 x plus 3. So we can see that the slope is negative 1/4. B is 3, that's our y-intercept. So we can plot our y-intercept and then use the slope. Let's use rise over run. So we have a rise of negative 1 and a run of 4. We'll go down 1 and to the right 4. And that gets us to this point right here. Now we could also treat that negative at the denominator instead of the numerator. So in that case, our rise would be 1 and our run would be negative 4. So we would go up 1 and to the left 4. And that gives us the equation of our line, the graph of our line. So using the slope and the y-intercept, you can graph the line by plotting the y-intercept and then using the slope to get to a second point. Draw the graph of f of x equals 2 to the x. This graph we're going to draw by plotting points. The equation 2 to the x is not a linear equation. It's an exponential equation because the variable's in the exponent. So we're going to choose some x's and find the y's. I'm going to choose x equal to negative 2, negative 1, 0, 1, and 2. We'll substitute that in. I'll do the easy ones first. 2 to the first power, that would be 2. 2 to the second power is 4. 2 to the 0 power is 1. 2 to the negative 1 power, that's reciprocal, 1/2. And 2 to the negative 2, reciprocal. The negative in the exponent is what tells us to do the reciprocal. And then we'll raise it to the second power. 1/2 to the second power is 1/4. So I'll use these ordered pairs, 0, 1, 1, 2, 2, 4, negative 1.5, negative 2.25, and if we follow our pattern, our right side goes to infinity and our left side is going towards our x-axis. So here's a sketch of the graph of 2 to the x. Thank you for checking out my videos. Have a great day.